AI assistants are getting, well, almost unbelievably powerful, right? They have thousands of potential skills they can tap into. But that creates this huge puzzle. When you give an AI a command, how on earth does it find the one perfect tool it needs in that massive sea of options? Today, we're going to dig into a really clever new solution to that exact problem. So yeah, this is the big question. When an AI has this arsenal of thousands, literally thousands of different abilities, how does it avoid just freezing up, paralysis by analysis? How does it pinpoint the exact right function for what you just asked it to do? It's a huge search problem, and honestly, solving it is crucial if we want AI to be genuinely helpful. Okay, I want you to picture this. Imagine your AI is a robot standing in the middle of a massive, super messy workshop. I mean, tools everywhere. It knows the perfect tool for the job is somewhere in all that chaos, but finding it quickly and efficiently, well, that's the real challenge. So how have people tried to tackle this before? Historically, there have really been two main ways of thinking about this problem. But, as you're about to see, both of them came with some pretty serious blind spots. So the first flawed method is what we can call an agent-only search. This is kind of like asking the workshop foreman to find a tool for you. The foreman, he knows where the big toolboxes, the agents, are, but he doesn't know every single little tool inside them, so the right tool gets completely missed if it's just tucked away in a poorly labeled box. Then you have the opposite problem, the tool-only search. Here, the AI can find that specific wrench you asked for, but it has absolutely no idea which toolbox it belongs to. It loses all that helpful context of what other related tools are nearby. So yeah, you can see both of these ways of doing it are just fundamentally incomplete. And the result of these flawed methods is pretty simple. You get a bad pick, a suboptimal selection. The perfect tool is sitting right there, but it just gets lost in all the noise. The AI either can't find it or it picks the wrong one, and boom, it fails to get the job done right. But what if, instead of just searching blindly through the mess, the AI had a perfectly organized map of the entire workshop? Well, that's exactly what this new solution provides. The solution is called Agent as a Graph. And what it does is, instead of that chaotic workshop, it creates a perfectly organized map. Every toolbox, that's the agent, and every single tool inside are all represented as connected points, or nodes, on a knowledge graph. All of a sudden, that messy workshop becomes this clear, totally logical diagram. And the result? It's a clear path to success. The AI's query can now navigate this map, finding the exact tool it needs and seeing the agent that tool belongs to all in one smooth process. No more guesswork. It's a game changer. So how does this smart map actually work under the hood? Let's break down the process. It's actually pretty elegant. It's really this powerful three-step process. First up is the initial scan. Think of this like a quick, broad search of the whole workshop for both tools and toolboxes that seem like they might be relevant. Next, you have smart re-ranking. This is where a clever scoring system organizes that initial list, weighing the importance of a specific tool against the context of its toolbox. And finally, graph traversal. And that's exactly what it sounds like. Once the best tool is identified, the AI simply follows the map right back to the agent that holds it. Simple as that. Now, the real key to this whole system is finding the perfect balance. The research found that just putting a modest emphasis on the agent, the toolbox, is what makes the entire search stable. This approach keeps the big picture in mind without losing the ability to zero in on a very specific niche tool when that's what's needed. So, the crucial takeaway is this really elegant balance. You can't ignore the specific tool, of course not, but you give a slight advantage in the scoring to the agent that contains it. This beautiful combination of specificity and context, well, that's the secret sauce. Okay, so this all sounds fantastic in theory, right? But does it actually work in the real world? Let's look at the numbers, because the results are pretty darn impressive. Using the agent as a graph method, there was a nearly 15% improvement in finding the correct agent. I mean, in this field, that is a huge leap in accuracy. And it wasn't just about finding the right one. The overall quality of the search results also improved by over 14%. So the system isn't just more accurate, it's fundamentally smarter about how it ranks things. Let's put that into perspective with a head-to-head comparison. The previous best method out there, something called MCP0, had a success rate of about 70%. Agent as a graph boosts that all the way up to 85%. That is a massive, massive jump in performance and reliability. And get this isn't some fluke that only works on one specific type of AI. The researchers tested this method across 8 different major AI models from Google, Amazon, and OpenAI, and that performance boost was consistent across every single one of them. This thing is seriously robust. And remember that secret sauce of balance we were talking about? They even found the perfect recipe. It turns out the system worked best when the scoring gave the agent, the toolbox, a 1.5 to 1 advantage over the individual tool. That little bit of extra emphasis on context, it makes all the difference. So, what does this all mean for the bigger picture? Why does a smarter map for AI actually matter to us? So, what's the big takeaway here? Well, first, creating a single unified map for both tools and agents is just a way more effective way to organize an AI's brain. Second, that delicate balance between context and specificity is absolutely the key to making it work. And what that all leads to is AI assistants that are way more capable and reliable. And maybe most importantly, this is a foundational step toward building massive AI systems where lots of different agents can finally work together seamlessly as a team. And that leaves us with a really fascinating final thought. We've just seen the power of creating a smart map for an AI's tools. But as these AI systems grow into these truly vast ecosystems of capabilities, it makes you wonder, what other kinds of maps will they need to build to successfully navigate not just their tools, but their own internal worlds? Something to think about.